Welcome back to Science Fantastic with Professor Michio Kaku. And Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing the world and touching our lives. And in this hour, once again, this hour is your hour. This is the time when you can take over the airwaves. This is the time when you can get on national radio and ask that question, make that comment that's always been bugging you. Okay, well, without further ado, let's move on to the first listener phone call.
Hey, this is Armand from Queens, and I listen to you on YouTube. I was wondering how fast we're moving through the universe. Can you give me a specific number? And I love your show. Thank you very much, and have a great day.
Well, you ask a simple but rather embarrassing question because there's no simple answer to your question. First of all, the Earth goes around its axis. In 24 hours, you go around the Earth. Circumference is 24,000 miles. You divide, and you come up with an astounding number that you are going around the Earth at the rate of 1,000 miles an hour. Amazing. You don't feel it, of course, because you're stuck here on the planet Earth. But literally, with regards to the space around you, you are traveling right now at about 1,000 miles an hour. But, of course, that's relative to what? Well, that's relative to the sun. But you see, we're also going around the sun, and we go around the sun. You can calculate it because the circumference of the Earth's orbit around the sun is 2 times the radius, which is 93 million miles, times pi. That's a huge number, and we go around it in 365 days. You divide, and bingo, you now calculate the velocity of the Earth going around the sun. But, hey, it doesn't stop there. We're also going around the galaxy. At the center of the galaxy, there's a gigantic black hole. It weighs 2 to 3 million times the mass of our own sun, and we are rotating around that black hole. And, well, using, again, simple geometry, you can calculate the velocity of your body going around the black hole at the center of the galaxy. But it doesn't stop there. You see, we are also moving around the center of the local cluster of galaxies, which include Andromeda Galaxy, and then that, in turn, is expanding with the Big Bang itself. So you can see that an answer to a simple question, how fast are you traveling, has many answers depending upon in relationship to what. In relationship to the diameter, the Earth's axis, you're traveling at 1,000 miles per hour. But with a little bit of mathematics, you can calculate how fast you're moving around the sun, how fast you're moving around the galaxy, and then how fast you're moving with respect to the Big Bang itself. So there are many answers to such a simple question. By the way, this had implications in a famous science fiction story written by H.G. Wells. H.G. Wells wrote a story since made into a movie where a man walks down a street and suddenly the gods in the heavens, as a quirk, decide to give him the power of creation itself. Any wish, and things will come true. So what did he wish for? Well, I'll tell you after the break. Welcome back to Science Fantastic with Professor Michio Kaku. Well, before the break, we had a simple question with a profound answer, and that is, how fast are we moving right now? Well, there's a science fiction story based on that idea. H.G. Wells once imagined that a young, ordinary gentleman, I think he was an accountant, very ordinary man, suddenly has the power to make any wish come true. And it's been made into several movies since then, by the way. And that man wishes for wealth, power, fame, glory, anything he wants comes true. And then he goes out partying with his friends, and then he looks in the sky, and as a simple lark, he wishes that the night would never end. That is, the earth would stop. Well, you can imagine the havoc that erupted at that instant when he said, I wish the earth would stop. Because the earth moves 1,000 miles per hour around its own axis, And by stopping, he basically upset the music of the spheres. And all of a sudden, everything that was moving at 1,000 miles per hour comes to an abrupt halt, and we are thrown into outer space. Chaos erupts as the entire planet Earth begins to disintegrate. And just before humanity dies, in the last microsecond, he wishes that he could turn back the clock and everything was as it was before he got the wish to be able to control all the forces of creation. So sometimes you have to be careful what you wish for. For God's sake, do not ask for the earth to stop if you have a wish. Okay, let's move on to the next listener phone call.
Hello, Dr. Michio Kaku. This is David from Imperial Valley, California. I'm calling just for a couple of reasons. If it took a form of energy to create the Big Bang as we know it, and it expanded and created the stars in the universe, everything that we know of, and it takes a form of energy for even human life and everything to be created, we say that there's dark energy out there as well. Can either form of energy, either dark or the residual energy that we see, can it be conscious? Now, that is my main question. Just like an animal that does not want to be found, is it there? We just haven't found it yet. Thank you, and you have a great day.
Okay, I think what you're asking is the universe conscious? I think that's what you're asking. And that depends on how you define conscious. And if you simply Google the word, you find that there have been 20,000 papers written by theologians and amateurs and professional scientists about the meaning of the word consciousness, and we still have no definition of consciousness. And so you're asking an even bigger question. Dark energy, the energy of the Big Bang, the energy which is pushing the galaxies apart, is it conscious? Well, I have my own theory of consciousness. If you ask most psychologists, they would say that animals are not conscious. Most psychologists would say that humans are conscious. We think about ourselves, we have self-awareness, we daydream, whatever, but not animals. Well, I tend to disagree. I have my own ranking of consciousness where I rank things on a scale, and I assign a number that's testable, reproducible, and measurable that ranks the consciousness of anything. I claim, and again, this is just me, I claim that the fundamental unit, the single unit of consciousness, is a single feedback loop, like a thermostat. You turn the thermostat and it gets cold. And so the room responds to the temperature around it. I think that is one feedback loop, and that's one unit of consciousness. I think that a plant has maybe 10 units of consciousness, because a plant has to know, it has to sense moisture, it has to sense the direction of motion, it has to understand the temperature surrounding it. So a plant may have 10 units of consciousness. And then we go to level 1 consciousness, which is that of an alligator. When you look at an animal, you realize the back of the brain of the animal is the oldest part of the animal. Take a look at your own brain and compare it with the brain of a snake. And you begin to realize that the brain of a snake is very similar to your brain, but it's the back side of your brain. That's called the reptilian brain, the brain of balance, the brain of territoriality, the brain of hunger and instincts. That's all way in the back of the brain, the oldest part of the brain. Then the brain evolved to the forward direction. Children, for example, babies when they're born, their brain is basically in the back, but gradually as the months and years go by, the brain develops then toward the center and then toward the front of the brain. And the front of the brain is the last part of the brain to evolve. So the center part of the brain is sometimes called the monkey brain or the limbic system. It is a brain found in emotional animals, not alligators, but animals that hunt in packs, that coordinate themselves in gangs like wolves. They have a very well-developed limbic system that talks about emotion, social hierarchy, ranking, which is, of course, much more difficult than most snakes. Snakes just have to know where's lunch and where's dinner. When I was a kid, I used to go to the Science Museum, and I used to stare at the snakes, and they would stare back at me. And then I wondered, what are they thinking? Well, I think I know the answer to that now. Reptiles have a reptilian brain, and what that reptile was thinking was, is this lunch? That's basically it. Their consciousness is the consciousness of a reptile. Then we have the center of the brain, the limbic system, the emotional brain, the monkey brain, and then finally the front of the brain, the prefrontal cortex, the thinking brain. So I think these are all levels of consciousness. Level 1 consciousness is reptilian consciousness. Level 2 consciousness is that of a mouse, that of a social animal like a wolf or a dog. And then we have humans. So what differentiates humans from dogs? Why are we different from reptiles? Reptiles have spatial consciousness. Their brain understands space. Where are they located? Where is the food located? Where is the mate located? The center of the brain locates your position in society. It's the social brain. Now, what is the human brain? I claim, that the human brain is the brain of time. That is, we daydream. We muse. We think about the future. We plan. We strategize. We can't help but think about the future. But animals don't. Let's do a science experiment to see if I'm wrong. Go to your dog tonight, or cat, and teach your pet the meaning of tomorrow. Well, I think you'll find that you can't. Animals do not understand the concept of tomorrow. Animals understand the concept of space, because that's where food is located. That's where their mates are located. They understand their ranking in society. If you're a dog or a wolf, you know who the top dog is. You know who the underdog is. But temporal consciousness, time, that's something that only we humans have mastered. Now, of course, bears will hibernate, but they hibernate by instinct. They don't say, bears do not say to themselves, I'm going to hibernate tomorrow. I got to pack my bags. I gotta get to rest because I know that in 3 months I'll wake up again. No, bears just go to sleep. They don't even think about it. It's just automatic because they have no sense of time. So then the question is there a fourth level of consciousness? Well, the first level of consciousness is space. The second level of consciousness is society. The third level of consciousness is time. And I claim that that's pretty much all there is. And so if the universe is conscious for some reason that I cannot fathom at the present time, but if the universe were conscious, it would have to be a consciousness greater than level 1, level 2, or level 3 consciousness. But for the life of me, I can't think of anything higher than space, time, and society itself. So is the universe conscious? I don't know. But I have a scale, a ranking, by which you can count the number of feedback loops and get a number for the degree of something being conscious. Let's move on to the next listener phone call.
Hello, Professor Kaku. This is Jesse from Houston. What is really gallium oxide, the transistor, and what can it do? I know it's coming, and I know it's here, or in the starting stages, or wherever it is. But can you give me some more information about gallium oxide transistors, and what can they do? What's the plans for the future for that? Thank you.
Okay, well, you asked a very interesting question. Recently, I was on Fox TV talking about the successor to gallium and to silicon. Let me explain. The way I presented it when I was on Fox TV is the following. If you're a little bit older, you remember vacuum tube radios and vacuum tube TVs. I still remember the old clunky TVs. You opened the back and you saw this forest of tubes in the back of your TV set. And if your TV went on the blink, which was every few months, you went to the supermarket and there was a tester. You would then put the vacuum tube in the tester, and the tester would tell you if the vacuum tube was blown out or not. Well, as you can imagine, things were clumsy. Things were awkward. Televisions were huge, bulky, but hey, that's the way it is, because everything was based on vacuum tube technology. Then came the transistor. That changed everything, Because all of a sudden, transistors could be miniaturized. Now, you cannot miniaturize a vacuum tube. It's only so small that you can make a vacuum tube shrink. But silicon you can put on a wafer and then carve up a circuit on that wafer of silicon to make a printed circuit. And that began the microchip. That allowed us to put millions of transistors on a little silicon chip. So what is a transistor? A transistor is a gate that governs the flow of electricity. That's really all it is. Let's say you have a river that has high voltage or high current, and then you have a valve. With a tiny little twist of your hand, you can determine the fate of billions and billions and trillions of water molecules. Okay? So a gate is very efficient. It allows you with a twist of your hands to regulate the flow of an enormous amount of water in a dam or in a pipe or in irrigation. Now replace the water with electrons and you can begin to understand the power of silicon transistors. With a slight little twist, with a little bit of voltage, you can control the voltage of a much larger stream of electrons, thereby amplifying the power of your twist. A small twist of a valve allows you to control a torrent of current flowing in the other direction. So since then, people have looked for a substitute for silicon, including gallium oxides. But now, people are realizing that even other exotic semiconductors only give you a little bit extra time. You see, we are entering the end game for silicon. Silicon chips cannot sustain calculations at the atomic level. They can go down to maybe 20 atoms, but anything smaller than 20 atoms across, transistors will fail. They'll short circuit. And so as a consequence, scientists have looked for replacements for silicon, like gallium oxide, or quantum computers. And that's what I talked about on Fox TV. Quantum computers could be the ultimate computer. Because if we're down to the size of atoms for transistors, why not make a computer out of atoms? And that's what a quantum computer is. And how powerful is it? Well, you know that a transistor basically counts zeros and ones. 0 for off, 1 for on, like you have in a valve, for example. A valve is either on or off. Everybody knows that. Valves are only in 2 states, on or off. But you see, in the quantum world, if you line up atoms so the North Pole points up, it can point up, down, or in between. That's where the quantum principle comes in. Instead of computing on zeros and ones, you can now compute on anything in between zeros and one. Immediately, you understand the power of this technology. Much more information can be encoded, not just in zeros and ones, but anything in between, called a qubit. So qubits are going to replace bits in the computer of the future. But what's the catch? There's always a catch someplace. The catch is that quantum computers are so delicate that if somebody sneezes in the other room, it's enough to jiggle your atoms and all the vibrations fall apart and your quantum computer is useless. But that doesn't stop the military from working on it. So, in fact, there was an article recently saying that the Pentagon is worried that the Chinese are jumping the gun and they're racing ahead with quantum computers. Well, yes and no. The Chinese are definitely interested in quantum computers, but let's not hyperventilate. It's still decades in the future. It's a very difficult technology to master. Like I said, someone sneezes in the other room and your electrons and atoms go flying in all directions, rendering them useless. So don't think we're going to have quantum computers anytime soon. But once we do get them, you can break any code on the planet Earth. I repeat, any code of any nation can be busted using quantum computers, and that's why the CIA is very interested in quantum computers. Okay, let's move on to the next listener phone call.
Hey, it's Armand from Queens. I was wondering, is there such thing as spontaneous combustion? I heard there was, but can you explain the science behind it? And do you think it's possible that people just explode out of nowhere? All right. Have a good one. I watch you on YouTube, by the way. Your show's great, and have a good day. Bye.
Okay, well, when I was a kid, I used to watch all the shows about the paranormal, all the shows about the mystic arts and things like that, just for the fun of it. And, well, after the break, spontaneous combustion was one of those things that caught my attention. And we'll say a few things about that after the break.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Well, before the break, we had a question about spontaneous combustion. And that is, can somebody simply burst into flames and be turned into ashes just by walking down the street? Well, as I mentioned, when I was a kid, I used to love reading everything. I mean, everything, including science fiction, as well as the paranormal and fantasy. I would read about Bigfoot and the Loch Ness Monster and ghosts and demons, and you name it, I was reading it. But after a while, after gorging on all this speculation about the paranormal, I began to realize something. And that is that unless there's definitive proof or testability of these things, we're going to talk about these things forever. Forever we'll be talking about ghosts and demons and witches because there's no proof one way or the other. And that's what I liked about science. In science you can decide yes or no whether there is a demon or a witch. You can do an experiment because you look at things that are reproducible, testable, and falsifiable. Now, one of the things I would come across was, well, first of all, the Loch Ness Monster and Bigfoot. And then I began to realize that to have a Loch Ness Monster, you have to have a breeding population. You just can't have one Loch Ness Monster because it has a finite lifespan and it would die, and that's the end of the germline. No, you would have to have a breeding population of maybe 50 to 100 Loch Ness Monsters to keep the species going, meaning that you would have skeletons, meaning that you would have all sorts of debris left over, not from one, but from 50 to 100 of these dinosaurs living in the Loch Ness area. And we don't find that. We don't find the litters of bones and carcasses of animals that the Loch Ness Monster ate. Same thing with spontaneous combustion. Maybe, maybe not. But it turns out that it's not reproducible. You can't do experiments on it. And most of the testimonies of spontaneous combustion are hearsay. There's no evidence you can point to in the laboratory. And so, well, it goes in what is called File 13. That is the file of things that, well, who knows for sure, but where's the proof? I mean, that's the bottom line. You have to be able to test these things. But I should also point out that we know a lot about what makes combustion possible. You have to have an initiating event that gives us, let's say, a spark. And then you have to have combustible materials and oxygen to get the fire going. So to our knowledge, the people who went into spontaneous combustion did not have on their bodies things that were readily combustible, like oils and gasoline and stuff like that. And so we'll have to put it on File 13. That is, incidences which are, well, who knows for sure whether they're true or not, but they're not testable. They're not falsifiable, and they're basically not reproducible. Okay, well, let's move on to the next listener phone call.
Hi, my name is Roger. I'm calling from 1450 KBKW, Aberdeen, Washington. And my question was just basically about cloning. I was just wondering if it's possible that a human has been cloned already, maybe not in America, but in other countries. And with the DNA, if that's more possible as in the past. I know we had cloned a sheep called Dolly. So I was just wondering if it's possible or has been done. Someone has cloned a human. That's all. Thank you.
Okay, well, the short answer to your question is, to the best of our knowledge, no human has ever been cloned yet. In fact, no primate has ever been cloned. We have cloned farm animals, Pets, for example, have been cloned for BBC television. I once went to a farm outside Dallas, Texas, where there are clones of cattle. Not only that, but clones of cattle. It turns out that a clone can also be cloned to give you a second-generation clone. And it's basically a farm where the owner speculates that at some point he may be able to sell the beef on the market. But right now it's still experimental, so he keeps these cloned animals on his farm, and that's where we took our camera. And then the question is, how far can you go? Well, as I mentioned, no primate yet has been successfully cloned, and that means, of course, that no human has ever been cloned at the present time. But is it possible? And the answer is definitely yes. Because at the molecular and the cellular level, we're not that much different from other animals in the forest. And so it's only a matter of time before somebody attempts this. Now, at the cellular level for embryonic cells, has there been mixing between animals and humans? And the answer to that is yes. A lot of the research, for example, has been done in China. And it does mean that we can treat ordinary human embryonic cells in the very same way that we treat animal embryonic cells. But there are laws. Certain nations are repelled by the idea of mixing animal and human DNA, and there are laws passed concerning cloning. Now, my personal point of view is this, and this is just my own personal point of view. I think, first of all, it's inevitable that at some point humans will be cloned, but it's not such a big deal. I mean, we already exist with clones called twins. And for that matter, who's going to clone themselves? The average person is not going to want to clone themselves to create a baby version of themselves unless, for example, unless you're a rich person who has no heirs, or perhaps no heirs you particularly care for. A rich person may simply will their money to themselves as children and start all over again as a millionaire. Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because, well, this hour is your hour. Okay, well, without further ado, let's get to the first listener phone call.
This is Karen Bang calling from California, listening on GCN. Neil deGrasse Tyson said there are green objects in space such as nebulae, but based on my research, these are mostly false color images. Are there any naked eye objects in space that would appear green without any type of false color or telescopes? Also, I understand that certain animals can see ultraviolet and infrared. Would this mean the visual spectrum will be larger for them, and therefore something that appears orange to us would appear red or yellow to them? For example, would a bee or a wasp see violet as blue and blue as green, based on the fact their spectrum is stretched? Or would it be possible the spectrum is flipped so that blue is red and red is blue? One last thing, if there are no green stars out there, wouldn't the discovery of a green star prove that it's manufactured by alien life? Thank you for your time.
Well, you ask a mouthful of questions, so let's try to break it down one by one. First of all, the human eye can only see really three colors. Now, you may say to yourself, that's kind of stupid. Everybody knows there's yellow and brown and magenta and pastel and all sorts of colors, and you're telling me that we can only see three colors? And that's right. If you take a look at the eyeball, there are basically three sensors there that sense red, green, and blue, the primary colors. All the other colors are mixtures of those three. Now, it turns out that some women can see a fourth color. There's a mutation which allows some women to actually see more colors than just three. But that's rare. Now, if you don't believe me, go to a TV set, especially the old ones, and look very carefully at the screen, and you'll see that the screen does not consist of hundreds of different colors at all. No, it consists of dots. Each dot is either red, blue, or green, the primary colors. Now, what is it that when you see yellow? Yellow, in some sense, is not a true color. It's a mixture of red, green, and blue. And so when you see yellow, you're not really seeing yellow in its true entirety. You're seeing an approximation to yellow. Now, take a look at the colors of the rainbow. When we were children, we learned about Roy G. Biv. The colors of the rainbow: red, orange, yellow, blue, indigo, violet. Roy G. Biv. And so these are all the colors of the spectrum, but your eyeball can only see 3 colors. Everything else is a combination of those 3 colors. So therefore, when you look at brown, you're not really looking at the elemental brown. You're looking at an approximation to brown. Now, look at the colors of stars. The colors of stars also go Roy G. Biv, because according to the Maxwell-Planck distribution of frequencies, color corresponds to energy. Blue is more energetic than red. Red has the least amount of energy. Blue has the most amount of energy. So something that is red hot is only maybe a few thousand degrees, but something that is blue hot can be tens of thousands of degrees. Now, if you don't believe me, get a match. Light a match, and you see that at the bottom of the flame is bluish, and at the top of the flame, it is reddish, which is exactly the colors of the rainbow. So the colors of the rainbow are there every time you see a fire. At the bottom of the flame is blue. At the top of the flame, it is red. Now, you asked about animals. It turns out that bees can see another color that we cannot, ultraviolet. Now, how do you prove that? Well, take a look at a flame. At the bottom of the flame is blue, but if you look very carefully, you'll see that the flame is, for the most part, floating invisibly above the wick. It's unattached. Amazing. So the flame is actually not the true flame. The flame is a column of hot gas, the bottom of which you cannot see. It's invisible, and that's called ultraviolet. And then the top of the flame is red, but there is a color beyond red, and that is infrared. And so your eyeball can only see a range of colors within a flame. You cannot see the entire flame at all. So next time you see a flame, look at the bottom and see that it's not attached to the wick at all, because there's ultraviolet radiation there. Now, bees can see ultraviolet radiation. Why? Because when the sun is covered or overcast, or when the sun is uncovered, the bees have to be able to lock on to nectar. They have to know where the flower beds are, whether or not there's clouds or not. Ultraviolet will go right through clouds. And that's why bees can see more colors than you. Bees can see the colors of flowers in ultraviolet as well. Now, some people think that nature created flowers to please humans. Well, not necessarily. Flowers are older than humans. Flowers go back before the dinosaurs. And so it means that the colors of flowers were not really created for our benefit, but for the benefit of insects, which have lived on the planet Earth much longer than us, and insects see colors that we cannot. So therefore, when you see the colors of flowers, you're only looking at a tiny fragment of the true colors of flowers, which can be in the ultraviolet range. So sorry about that. You do not see the universe as it really is. You see only a sliver of the universe with your eyeball. Welcome back to Science Fantastic with Professor Michio Kaku. Well, let me just mention that the previous caller asked about the different colors of the rainbow and why there are not any green stars. Well, actually, there are green stars because green is relative. Green is a primary color, and it corresponds to one of the colors of the rainbow. And the colors of the rainbow, in turn, correspond to the color of stars. Therefore, stars can come in all the colors of the rainbow, including green. But of course, when we talk about stars, we talk about blue giants giants and red dwarfs. But no, there are other colors of stars because temperature corresponds to a color according to the Stefan Boltzmann law. Okay? Well, anyway, let's move on to the next listener phone call.
Hello, Dr. Kaku. This is Jesse from Houston. I had a question for you that's a little boggling my mind. You probably heard this before, being in string theory, but if I had a rocket, it's barely in space, barely floating right outside of Earth, and I got a ship big enough, the fuel's ready, enough fuel to go the speed of light. Okay? Now, on Earth, there's a beam of light that starts. We both start at the same time, going at one destination. It doesn't matter. That's not part of the question. We go one destination. Of course, the beam of light is going faster than me. Now, calculated it through the fuel they use, you go the speed of light. It takes 4 years, whatever year. Now we're both going the same speed. Now, if I go in a second gear, if you will, and I go, say, 5 miles faster than the speed of light, if I look back from my rocket that I'm in, what do you think you see in between me, the rocket, going faster than the speed of light, and the speed of light that is, of course, going the speed of light, the beam light, the light of beam? What do you think you see in that gap? Future, past, parallel universe? What do you think? Thank you. Love your show.
Okay, well, you ask a series of questions, so let's try to break it down. First of all, velocities do not add in relativity theory. For example, if you are on an escalator and you throw a baseball, then the question is, how fast is the baseball going? Or for that matter, if you're on a jet airplane and you fire a machine gun, how fast is the machine gun bullets going, given the fact that you are boosting the projectile by being on an escalator or by being inside a jet? Or people ask the question, if you're in a rocket ship near the speed of light and you turn on a flashlight, what is the speed of the flashlight, given the fact that you have the speed of the rocket originally? Now, common sense says you have to add the two. You add the two, the velocity of one plus the velocity of the other is the net velocity. But you see, in relativity theory, no, that's not true. Velocities do not add. And that's the key to the whole puzzle. So if you are in a rocket traveling near the speed of light and you throw a baseball, in principle, the baseball should exceed the speed of light because you add velocities. But nope, velocities do not add. If you do the math, it comes out very clear. But common sense tells you that you can always add velocities. Therefore, if you are in a rocket ship and turn on a flashlight, how fast is the flashlight moving? At the speed of light. Now, that seems to violate the common sense that we've learned ever since we were kids. But hey, your common sense is wrong. Now, this gets even crazier. If I have a rocket ship with a flashlight inside, how fast is the flashlight moving with respect to someone inside the rocket and with respect to someone outside the rocket? Well, common sense says you should have two velocities. The velocity of the light in the rocket and the velocity of the light outside the rocket. Nope. When you actually do the experiment, and the experiment's been done, when you actually do the experiment, the speed of light is the same no matter how you measure it. Now, you may say to yourself, that's impossible. That's incredible. No, it violates common sense. How is that possible? And the answer is it actually dawned on Einstein himself in the spring of 1905. And that is, your brain has slowed down. Time slows down inside the rocket. You don't notice it, of course, because everything else has slowed down in the rocket. But that's how you resolve all the paradoxes. We forget something. We assume that your brain travels at the same velocity, that you think at the same velocity of a person sitting at rest. No. If you're in a rocket ship, your brain slows down. Everything in the rocket slows down. And that's why everything you measure slows down as well. And that is how you resolve all the paradoxes. In fact, Einstein himself was puzzling over this for about 10 years. For about 10 years, when he was 16 years old to about the age of 26, he pondered this question about how can you go faster than the speed of light? And then you realize you can't, because every time you try to go faster than the speed of light, your brain slows down and therefore you cannot measure it. Now, what does it feel like? That's the question that came in. What do you see if you're in the rocket traveling near the speed of light? And according to relativity, things seem normal. Everything else has slowed down, but your brain has slowed down too, so you don't notice it. I once saw a science fiction movie, one of the worst science fiction movies ever made, and the aliens kidnap some Earthlings and put them in a flying saucer, which then whizzes out near the speed of light. And then the alien says to the Earthlings, "Look at your watch." And the Earthlings in the movie say, my God, my watch has stopped. Einstein was right." You see, no, that's not how it works. Inside the rocket, your brain has slowed down, and therefore when you look at your watch, it seems normal. Because the watch is slowed down, your brain has slowed down, everything has slowed down. And that's how you resolve all the paradoxes of relativity theory. People forget that. You have to take into account that your brain has also slowed down, so everything you measure is screwed up as a consequence. In other words, relativity works, and we prove it every day. In fact, in our physics class, we actually prove some of these things right there in front of people using laser beams in a fiber optic cable. Okay, well, let's move on to the next listener phone call.
My name is Dr. Romeo Sarkar. I'm calling from India, Calcutta. I'm a very big fan of you and your communicative skill. What's your views about panpsychism? My question is, sir, what's your views about panpsychism? That even electrons are conscious, as if they are waves filled in the rubric of the universe itself. Please shed some light on this, and let all of us be enlightened, sir. Thank you very much. My sincerest respect. Thanks again. I'd love to hear from you. Thank you, sir.
Well, you're calling all the way from India, and unfortunately, the reception was not so good, so I didn't quite get the message, but let me try to answer what I think your question was. Your question talks about the quantum theory and how do we view, like, the electron. And we look at the electron in two ways. First of all, the electron has an antiparticle called the positron, which has positive charge. So in quantum mechanics, you have positive charge particles and negative charge particles. They are antiparticles of each other. When they meet, they annihilate. That's yet another duality in terms of particle-wave duality. People wonder, well, the electron, is it a particle or is it a wave? And it turns out that we physicists believe that the electron is a particle. It is a particle. However, the probability of finding that particle at any given point is given by a wave. And that's how a particle and a wave can be more or less the same thing. They really are a little bit different. So what is the electron? The electron is a particle. It's a dot. However, the probability of finding that dot is given by a wave. And so when the wave is maximized at a certain point, that's where the electron is most likely to be, and that's why we say that's where the electron is, even though it's an average effect. Now, to make things even more complicated, we now believe that this dot could actually be a string, and I'll talk about that after the break. With Professor Michio Kaku. And before the break, we had a question I think the caller was getting at, like, what is an electron anyway, a subatomic particle? Well, as we mentioned before, we think that an electron is a dot. However, in quantum mechanics, the probability of finding that dot at any given point is given by a wave. And so when the wave gets larger, we think that's probably where the electron is located. And then the question is, well, what is this dot we're talking about? Is it really a dot? Well, we think that no. If you had a super microscope and could look at an electron, we think that it's actually a rubber band. a rubber band or a string that vibrates. And when it vibrates at different frequencies, that's why we have different subatomic particles. And that's why we have so many subatomic particles. Why should Mother Nature be so malicious to give us all the subatomic particles in nature? Hundreds of subatomic particles. When I got my PhD at Berkeley years and years ago, I had to memorize the names of all these god-darn subatomic particles. In the future, I would hope that to get a PhD in physics, all you would have to do is say string theory and get your PhD. Because we think that a vibrating string can, in fact, generate all the particles of nature. Now, of course, this theory is not proven yet, but we hope that the Large Hadron Collider will one day allow us to calculate and detect the higher resonances, higher octaves of the string, and we think that's dark matter. Dark matter is a substance that has not been found yet in the laboratory. We know it exists out there in the galaxy, but we think that dark matter could be the next vibration of tiny vibrating strings. Okay, let's move on to the next listener phone call.
Hello, this is Albert from San Jose, California. I catch you usually on online, so I don't have a radio station call letter. First of all, it's a great honor to speak to you, sir. I really do enjoy your show. I have a question, though, in regards to classification of our civilization from type 0 to type 1. And your estimate would be about 100 years from now. I've heard you mention that before. How or when can you classify us as a type 1? What great event would take place in order for us to convert over to be seen as type 1? Or is it a collection of events? I was just curious about that. Thank you very much. You take care of yourself. Thank you.
Okay, well, we scientists get frustrated when people talk about alien civilizations in outer space and little green men, because we scientists like to rank things. We like to give numbers to things. We like to quantify things, not just BS about them at the dinner table. So Nikolai Kardashev in Russia gave us a ranking for extraterrestrial civilizations, type 1, 2, and 3. A type 1 civilization absorbs all the light that falls on it from the sun. They are type 1 like Buck Rogers or Flash Gordon. They would exist in a planetary civilization. For example, they would have mined the oceans, they control the weather. Anything planetary is within their domain. Then eventually they exhaust the power of their planet and they begin to absorb the energy of a star. This is called type 2, a civilization like in Star Trek. In Star Trek, they actually can ignite stars. And type 3 is galactic, whereby you roam the galactic space lanes like in Star Wars. And then the question is, what are we on this cosmic scale? Welcome back to Science Fantastic with Professor Michio Kaku. And before the break, we had a question about our civilization. We physicists rank civilizations by energy. We don't talk about little green men. We don't talk about fantastic things of encountering aliens in space. No, we physicists like to quantify things. And we quantify them by energy. Type 1 would be planetary, for example. Type 2 would be stellar. Type 3 would be galactic. Now, what are we on this cosmic scale? Do we control the weather? Do we control stars and black holes? Do we roam across the galactic space lanes? No, we're type 0. Carl Sagan, however, gave us a more accurate estimate. He devised a logarithmic scale, and he calculated that we are about 0.7. In other words, we're converging on being a type 1 civilization. And you can actually see this culturally in fact. For example, English will probably be the future language of this Type 1 planetary civilization. We talk about sports. We already have planetary sports in the form of soccer and the Olympics. We actually have a planetary music evolving, youth music, rock and roll, rap music, and stuff like that. We have a planetary culture forming, high culture, with Chanel and Gucci. And so we're beginning to see planetary cultural artifacts being developed in our society, but it won't be probably for another 100 years. And why 100 years? Because in 100 years, we will be creating as much energy on the Earth as light falls on the planet Earth. Right now, we only use a fraction of the amount of light energy that falls on the Earth. An advanced civilization would use all of it, and that is Type 1. Now, a Type 2 civilization is immortal. Nothing known to science can destroy a Type 2. Ice ages and even a supernova cannot destroy a Type 2 civilization. So we should see them. We've looked in outer space for Type 2 civilizations, and so far we have not found any at all. Sorry about that. And one day I was in the London Planetarium giving a talk about this, and a little boy comes up to me, must be about 10 years old, and he says to me, "Professor, you're wrong. You're wrong, Professor. There's Type 4. And I said to the little boy, "Now, come on, give me a break. I mean, after all, there are planets. There are stars, and there are galaxies. That's it, kid. There's nothing beyond planets, stars, and galaxies." But the little kid tugged on my pants and said, No, Professor, you're wrong. There must be Type 4. And then I realized that, hey, maybe he's right. Maybe I was wrong. Maybe there really is a Type 4 civilization beyond galactic, like what we find in Star Trek. In Star Trek, there is a civilization beyond galactic, and that is the Q. The Q has the power of a god, able to manipulate galaxies if he felt like it. So maybe there is a Type 4. However, we are stuck with Type 1, but the transition between Type 0, where we are today, and Type 1 is potentially catastrophic. Because a Type 0 civilization still has all the savagery of its past emerging from the swamp. And as a consequence, it's not guaranteed that a civilization will go from Type 0 to Type 1. They could blow themselves apart. They could ruin their civilization with pollution. All sorts of things can happen to prevent them from going from Type 0 to Type 1. But that's where we are today. We are at perhaps the greatest transition point in the history of civilization. The transition from a savage Type 0 civilization to a peaceful planetary Type 1 civilization. And we're privileged to be alive to see this transition happening right before our eyes. Every time I read the newspaper, I realize that I'm reading about the birth pangs of the birth of a planetary Type 1 civilization. Okay, let's move on and take the next listener phone call.
Hi, this is Armand from Queens, New York. I was wondering, you know how they have bicycles that have an assist with the battery? It's like an electric bike, a semi-electric bike. I was wondering if there's a way to be able to charge that battery with the same pedal motion and then keep using that battery as you're going. Thank you very much, and have a great day.
Well, the short answer is yes. You can convert mechanical motion into electricity. In fact, some people think that in the future, instead of having to charge up your cell phone or whatever, we'll have wearable computers that are energized by the motion of your body. So even the simple muscular motion of your body would energize the electric devices that you have without having to have those pesky lithium-ion batteries. And here's how it works. Think of a dam. In a dam, you have water going over the dam, and it spins a wheel. The wheel, in turn, is connected to a magnet, and the magnet spins because the wheel is spinning. The magnetic field in turn pushes the electron in a wire and therefore moves the electron in the wire, creating electricity. That's how hydroelectric dams work. That's how we energize a lot of the homes around the country using hydroelectric dams. That's how bicycle lamps work. Bicycle lamps work because the motion of the wheel turns a tiny dial which spins. Connected to the dial is a magnet. The magnet in turn is very close to a wire. The magnet then pushes the electrons in the wire, creating a current which energizes your light bulb. And that's how bicycle batteries work. And one day, perhaps we'll even energize our home devices, our portable devices, using the bodily motion of our movement. The very fact that your body moves creates vibrations, which in turn can push against electrons, giving you a current. So perhaps in the future, you're not going to have to worry about batteries at all. Well, we only have a few minutes left in Science Fantastic, so let me take a few of the email questions that I get, because not everybody wants to be on national radio. Some people are shy, but they email me questions, so let me answer a few of these questions. One question that I get is about the Space Force. The President of the United States has said that we have to have not just the Air Force, not just the Army, but a Space Force, because space is where all the action is. Well, there are pluses and minuses to both sides, so let me give you the pluses and minuses. On the plus side, well, let's be serious. Let's not be naive. The Chinese and the Russians, they too are looking at the militarization of space. Let's not be naive about this. The Chinese, about 10 years ago, even shot down one of their own satellites using one of their satellites, proving that they have killer satellite capability. In fact, the destruction of one of these Chinese satellites created a debris field of about 2,000 pieces of debris, and scientists around the world were horrified that a killer satellite from China created all this junk. And we scientists on the Earth now have to compensate for that whenever we shoot one of our satellites through this junk field created by the Chinese. Well, the point here is that the Russians are experimenting with this, and we are too. Let's be clear about this. And therefore, there has to be a cop on the block. And that's where the Space Force comes in. Not that it's going to terrorize everybody, but it's going to be basically a peaceful force like a cop on the block that regulates the traffic, makes sure that things are peaceful, and that things don't get out of hand. That's the plus side. The minus side, however, is, well, if war does break out, who is the most vulnerable? We are. We are the ones that depend upon satellites for communications, for early warning, for the internet, for GPS. If a war were to break out, we would be the first to feel the effects. So let's say a small country, even like North Korea, could in principle detonate an atomic bomb over Kansas. Placed just right, it would create an electromagnetic pulse that would paralyze our communication system. Think of two gunfighters, where one gunfighter throws sand in the enemy's eyes, blinding him in the opening shots of a war. Even if the other side has bigger weapons, these bigger weapons are useless because you've now blinded them with the electromagnetic pulse. The electromagnetic pulse is real. It's not fictional. We've actually created an electromagnetic pulse back in the 1960s by accident. And so this means that we have to be very careful. If we begin to militarize space, we need a treaty, like the Outer Space Treaty of 1967, to regulate this, because we are the most vulnerable to a space war. Good day.